Hello, in this video I will explain geometric sequences for IB. Definition of a geometric sequence. Geometric sequences are number sequences. Each term is found by multiplying previous term with a constant value. As you can see in this example, our first term is 1 and the second term is expressed by multiplying first term by 3 here. And third term, again, we multiply the second term by 3 times 3. And then times 3, 27, times 3 is 81. So this is a geometric sequence. This constant value is called common ratio, and it is represented by R. For this series, we can say that our common ratio is 3. If we cannot see the common ratio directly, what we can do is divide a previous term to its predecessor. For example, 1 and 3, if we divide 3 by 1, we get 3. If we get second term and third term, u2 equals 3 and u3 is 9, we will divide u3 by u2, so 9 over 3, again we have 3. So if we cannot directly see it, we can divide the terms to each other to find the common ratio. Let's look at some examples. In the following geometric sequence, find the value of common ratio. Part A, 2, negative 6, 18, negative 54, and so on. So if we cannot see that, common ratio in here is multiplied by negative 3, again multiplied by negative 3, multiplied by negative 3. If we cannot see it directly, we can divide negative 6 by 2, and we have negative 3. Or we can divide 18 by negative 6, 18 by negative 6, again we have 3, negative 3. So we can say that common ratio of the sequence is negative 3. Part B, we have m squared, m cubed, m to the power of 4, and so on. So if we divide m squared by m, we have m. If we divide m cubed by m squared, we again have m. We can do the same thing for m to the power of 4 divided by m cubed, again m. So we can say that common ratio of the sequence B is m. Final one, C. This is a decreasing sequence, 9, 3, 1, and so on. So if we divide 3 by 9 equals 1 over 3, or we can divide 1 over 3, again we will have the same common ratio. So we can say that common ratio of this sequence is 1/3. So fourth term will be actually 1/3. Be careful in here. Part C is a decreasing sequence and common ratio is a fraction, less than 1. Also in part A, be careful in here, it is alternating sequence because two positive numbers, second term is negative, third term is positive, fourth term is negative. If a sequence alternates, then its common ratio must be negative number. Because negative times negative gives us positive, that's why the sequence alternates. So these important two common ratios we need to be careful of. Next example here, in a geometric sequence, the first term given as 3 and common ratio given as 2. So 3 is first term, common ratio R equals 2. Part A says write the first 3 terms of the sequence. So I will start with 3, this is our first term. To find the second term, I will multiply it by 2, so second term is 6. And to find third term, I will multiply second term by 2, which is 12. So I can write 3, 6, and 12 are first 3 terms. Part B, it says find the seventh term. So let's write down the first 3 terms quickly. 3, 6, and 12. So fourth term is 24, fifth term is 48, sixth term is 96, and seventh term 192. As you can see, the sequence is getting bigger and bigger, so we need to come up with a practical formula to find these terms quickly and easily. So it's part C. Part C says write a general term. A general term gives us any term we want and we will calculate it easily. So I will write down the terms here. First term is 3. Second term is 3 times 2. Third term is, instead of writing 6 times 2, I will write the second term 3 times 2 and then multiply it again by 2. And fourth term will be 3 times 2 times 2 times 2. So let's look at the numbers. The first one is 3, second one is 6, the third one is 12, and this is 24. So as you can see here, there is a pattern here. First term stays as it is. Second term is multiplied, 1 common ratio, 3 times 2 equals 6. Third term multiplied 2 times by common ratio times common ratio. And fourth term is 3 times common ratio, 3 times 1 common ratio, 2 common ratios, 3 common ratios. So if you follow this pattern here, un will be first term times common ratio times common ratio, and it will stop again with common ratio, and there are n minus 1 common ratios. So instead of writing this way, we can say that nth term un equals first term times common ratio to the power of n minus 1. So this actually summarizes the general term formula. This formula here, un and n term, will be given in your formula booklet. And it will look like this. un is nth term, u1 times r to the power of n minus 1. u1 represents first term, r represents common ratio. Example, show that this is a geometric sequence. So our terms are negative 18, 6, negative 2, 2/3, and continues. So we can directly see the common ratio by looking at negative 18 and 6, but we can divide the terms to each other to find it as well. So if we divide 6 by negative 18, we get negative 1/3, or we can find the same common ratio. Negative 2 and 6, negative 2 over 6 is negative 1/3 again, or 2/3 divided by negative 2, again we have negative 1/3, because 2 and 2 cancels each other and we have negative 1/3. Since the common ratio exists, then we can say that yes, this is a geometric sequence and common ratio is negative 1/3. Part B, it says find un and then find u11 as fraction. So let's find it. Un formula is this, u1 times r to the power of n minus 1. This will be given in the formula booklet. So I will just substitute first term and common ratio into this formula. So un equals, first term is negative 18 times negative 1/3 to the power of n minus 1. So in this formula, we will substitute 11 to find u11 as a fraction. So u11 equals, negative 18 stays as it is, and negative 1/3 to the power of 10, because if we substitute 11 here, 11 minus 1 is 10. So this is our common ratio. In here, because the power is an even number, this negative number will be positive, and there is a negative number multiplied, so the result will be negative. So we can say that the answer will be negative 18. This negative comes from here, not from here. So negative 18 over 3 to the power of 10. This is a big number, so I will leave the answer like this. Example, first term of a geometric sequence u1 equals 2 and common ratio r equals negative 3. Which term of this sequence is negative 39,366? So this is a big number. In this question, we need to use calculator. So first term is given as 2 and common ratio given as negative 3. We need to write down the general term of this geometric sequence. So this is our general term formula. Un equals u1 times r to the power of n minus 1. I will substitute first term un equals 2 times, and then negative 3 is our common ratio, and power will be n minus 1. Next, we need to write down this general term as a function to be able to calculate with the calculator. So instead of writing un, I will say this is a function f of x equals 2 times negative 3 to the power of, I will change the variable n to x because that's what the calculator uses as a variable by default, x minus 1. And next we will use the calculator and to figure out which term is negative 39,366. So let's do it. On the main screen, I will choose a new document. I recommend always start with a new document. And then I will add graph. And I will write down the function here, which is 2 times negative 3 to the power of x minus 1 here. And I'm not interested in its graph, I am interested in table of values. So to do that, I will click on menu and I will go to table and I will click on split screen table. When I do that, this gives me the terms of the sequence. First term is 2, second term is negative 6, third term is 18, and so on. So I'm trying to find 39,366 term, which is 10th term. As you can see, 10th term is negative 39,366. This is our answer. So we found that U10 here, U10 equals actually negative 39,366. So 10th term is our solution. Next, we will look into applications of geometric sequences. There are different question types that are modeled by geometric sequences. So, for example, investment and interest questions. A bank gives a simple interest or compound interest, or population growth, or depreciation value of a car. These sort of problems are modeled by geometric sequences. So let's look at our first example. Example, 3,000 euros is invested for 4 years in a bank. How much will be the total amount after this time period? Part A, if the bank gives simple 6% interest a year. Part B, if the bank gives 5% compound interest a year. So let's start with part A. 3,000 euros is our original amount or principal value. And then we will multiply this by 6% because 6% simple interest is given by the bank. So 6 over 100, and then it is equal to 180, which means bank gives 180 euros every year and add to the principal value of over 3,000 euros. But in 4 years, the bank will give 4 times 180, 720 euros. So after 4 years, at the end of 4 years, 3,000 euros are original amount plus 720 euros as interest. So in total, there will be 3,720 euros in the account. Now let's look at part B, compound interest. Part B. So this time again we have 3,000 euros at the beginning, and bank gives 5% interest, which is 150 euros for the first year. And this 150 will be added to the original amount, 3,000. Then there will be 3,150 euros in the bank at the end of the first year. Now, it is not like simple interest. Right now, second year, interest will apply to this amount, 3,150 euros, not 3,000 again. So right now in the bank, there is 3,150 euros at the end of first year. So bank will give 5% interest to this amount. So the bank will give 157.5 euros, and if we add this to our amount here, 157.5, 3,307.5 euros will be at the end of the second year in the bank. So this pattern works differently than simple interest. We can actually model this question as a geometric sequence. So let's do it. Let's create a geometric sequence, but this is a different kind of geometric sequence. This time we don't have first term, we have zero term, which is the beginning value amount in the bank. 3,000 euros will be our zero term, not first term, but zero term. And the common ratio is not 5%, because if you look at the pattern, 5% applies, and then this amount is added to the original amount, 3,000, and then we get the result. So this original amount will be 100%, because 5% interest, 100% original amount. So in the end, we have actually 5% plus 100%, 105%, or as a decimal value, 1.05. This is our common ratio. So let's see if the formula works or not. At the end of first year, U0 should be multiplied by the common ratio. So 3,000 is our zero term times common ratio 1.05, and the result is 3,150 euros. So we directly get 3,150 euros with this formula. Just like at the beginning of the solution, we have the same answer. So let's apply to this formula in the second year. Second year, again, 3,000 euros times 105. This is our first year amount. This amount will be multiplied by the common ratio again, because this is first year. Second year, we will multiply the whole thing again by common ratio, and then we have 3,000 times 1.05 squared, and the result is 3,307.5, which is the same result we got here. So the formula works. If we generalize this pattern, this formula, after n years, un general term will be u0 zero term times r to the power of n. This is different than general term of a geometric sequence, because in that formula we have nth term, we have first term, and then r to the power of n minus 1. But in compound interest, we will use this formula. Nth term in here, zero term, and r to the power of n, not n minus 1. And this is the pattern, as you can see. So, if we confirm the formula works, let's calculate after 4 years what will happen. We are looking for u4. Fourth term equals zero term times r to the power of 4. So 3,000 times 1.05 to the power of 4, then 3,646.52 euros will be in the account after 4 years. In the formula booklet, you will see a compound interest formula, which will given be like this. Fv equals Pv times 1 plus r over 100k to the power of kn. So there are too many variables, and let's see what they mean. Fv means future value, Pv means present value, n represents number of years, k represents number of compounding periods per year, and r percent annual rate of interest. So if it is 5%, we will take r as 5, not 0.05, but just 5, because 5%. And let's apply this formula to our previous example. If it works as the same way, we found this answer here. So I will apply this formula here. Again, same question, 4 years, 5% compound interest. Future value is what we want to find. Present value, 3,000, is our original amount. 4 years is number of years, because in the question it says 4 years. Because the compound yearly, which means there is only one time a compound in the bank, so k must be 1 because it compounds once a year. R percent, r equals 5, and if we substitute this into formula, 3,000 times 1 plus 5 over 100 to the power of 4. Normally there is 100 times 1 and here 4 times 1, but we don't have to write times 1 because it will not change the answer. And if we calculate it, we have this formula and we have the same answer as you see. So the formula works. It is up to you. You can directly use compound interest formula or you can model it by yourself in the exam. Example, $2,000 is invested in a bank at the compound interest rate of 5.4% per year. Write an expression of the investment for n years. How much money will be in the account after 6 years? Find the minimum number of years for the investment will exceed $4,000. So part A, let's start. This is a compound interest question, so we can use future value formula from the formula booklet. And we are looking for future value equals present value is given as $2,000. 1 plus R is 5.4 over 100. K is 1 because it compounds yearly, so there will be only one compounds every year. So K is 1, so to the power of n. Or you can model as a geometric sequence as we did in the previous example. We can say that zero term is $2,000. Common ratio R equals 5.4% plus 100% original amount, 105.4%, or as a decimal number 1.054 is our common ratio. So if we model this as UN equals 2000 times 1.054 to the power of n. If you look at future value formula and this formula, you will see that the brackets also gives us 1.054, so they are the same thing. We can use either formulas. It will work just as they're supposed to. So part B, it says how much money will be in the account after 6 years. So we are looking for 6th term. So U6 equals 2000 times 1.054 to the power of 6, which is $2,742.04. We could use the future value formula. It will give the same answer. Part C is a calculator question because it says find the minimum number of years for the investment will exceed $4,000. So we are looking for UN is greater than 4,000. Our UN formula is this 2000 times 1.054 to the power of n. When will this exceed 4,000? So if we write down our general term as a function f of x, so 2000 times 1.054 to the power of x is greater than 4000. So we can find the answer. So let's use the calculator. So home screen, I will start with a new document, and I will don't save the previous one, and I will add graph, and I'm going to write down our function 2000 times 1.054 to the power of x. I'm not interested in the graph. I'm not going to zoom out to see how it looks. I'm directly going into table and split screen. So this gives me the investment of the bank. So first year there will be this amount of money. At the end of second year there will be this amount. I am looking for when the interest will exceed 4,000. Seventh year there will be $2,890 in the account. 8th year 3,000. 9th year 3,200. 11th year, 12th year, 13th year, and 14th year. So after 14 years there will be more than $4,000 in the account. So our answer is 14. Example, in a farm there are 70 sheep and their population increases 9% every month. Find how many sheep will be there after 12 months. Just like interest questions, population growth questions can be modeled by using geometric sequences. So assume that our zero term in this case is 70 because there are 70 sheep at the beginning. And our common ratio is 9% from the increased value plus 100% up to original amount, 109%, or as a decimal number 1.09. So our nth formula will be u0 times r to the power of n. So how many sheep will be there after 12 months? We are looking for actually 12. So if I substitute 70 for 0 and 1.09 for common ratio, and I will use general term, so u12 equals 70 times 1.09 to the power of 12. It is very similar to our interest questions. So the result will be u12 equals 196.887 sheep. So because there cannot be decimal number of sheep, we need to round this number. So we can say that there will be 197 sheep on average in this farm. Exam type questions. Question number 1. The first four terms of a sequence are 12, 36, 108, and 324. Show that this is a geometric sequence. Part B, find the nth term of the sequence. And second part, find that which term is 2,125,764. So let's look at the sequence here, 12, 36, 108, 324. If this is a geometric sequence, then there must be a common ratio. So let's check if there's a common ratio or not. If we divide 36 by 12, we get 3. So 3 could be a common ratio, but we should confirm by using the other terms as well. This is the common ratio. If we divide 108 by 36, or if we divide 324 by 108, we always get the same result, 3. So we can confirm that this is a geometric sequence and common ratio is r. Common ratio r is 3. So part B, it says find the nth term. So nth term will be un equals u1 times r to the power of n minus 1. This is from the formula booklet. So un equals, our first term is 12 and r is 3. So 3 to the power of n minus 1 will be the general term or nth term of this sequence. And second part of the question, it says find that which term is 2,125,764. So this is a big number, which means we need to use a calculator to solve it. Un equals this number, and if we use calculator, u12 equals 12 times 3 to the power of 12 minus 1, and u12 is this. So 12th term is actually this number. But let's double check this answer by using the calculator. I'm going to use the calculator to solve this question. So I will start with a new document here and I will add graph. And I'm going to write our nth term by using the x variable. So 12 times 3 to the power of x minus 1. So this is the graph of it, but I'm not interested in the graph. I am interested in table of values. So I'm going to click on menu here and then table and then split screen. We are looking for which term is actually 2,125,764. So fourth term, fifth term. As you can see, the sequence actually rapidly grows. So we got the number 12th term is this. So 2,125,764. So 12 is our answer. Exam type question. m plus 1, 3m, 14 minus m are consecutive terms of a geometric sequence. Find the possible values of m. So we are looking for more than one answer. If this is a geometric sequence, then it must have a common ratio. And common ratio is found as dividing the terms to each other. So we will divide m plus 1, 3m, 14 minus m, these are the terms. If we divide common ratio 3m by m plus 1, this gives us common ratio. We can find the same common ratio if we divide 14 minus m by 3m. So the answer of these two fractions must be equal to each other because it gives the common ratio. Now we can find the value of m by solving this equation. If we cross multiply here, then we will have 9m squared, 3m times 3m, 9m squared equals m plus 1 times 14 minus m. And if we distribute here by using FOIL or whichever method you want, we have this 14m minus m squared plus 14 minus m. And if we move 9m squared to the other side and reorganize the terms, we have this quadratic equation. 0 equals negative 10m squared plus 13m plus 14. We can solve this equation by two methods. Either we can factorize it or we can use the calculator. Let's do both. If we factorize it, 0 equals negative m plus 2 times 10m plus 7. This is the factorized form. And the solution will be either this factor will be 0 or this factor will be 0. So in here, m is either negative 2 or m is negative 7 over 10. This is the factorization method. We can use calculator as well. To do that, we will rewrite the equation by using x. So instead of by m, I will just use x. Negative 10 x squared plus 13x plus 14. So let's do it on our calculator. I will start with a new document. I will not save the previous one. And I will add a graph. And I'm going to write down my equation here. Negative 10x squared plus 13x plus 14. So this is the graph of it. I'm interested in zeros. So let's move this here. So we have two solutions. Either this 0 or this 0 will be our answer. So we will click on menu here, analyze graph, and I will select 0. And I'm going to approach to 0 and I will set the boundaries. So it's either 2. 2 is one solution. And I will again go to analyze graph and 0. And I will again here negative 0.7 is the other solution. So we have the same result as we found in factorized method. These slides are created with part of a digital textbook. Only some of the examples and questions appeared on the video. The book has 9 sections and covers number and algebra unit. The book is created with minimalist design language. Easy to follow and easy on your eyes with its dark theme. This is an interactive textbook. Other than written explanations, every section has video tutorials. All you need to do is click on video boxes and start watching. At the end of every section, you will find exam type questions. These questions directly prepare you for IB exam. They have written solutions as well as video solutions. Solutions are prepared in detail to make your understanding easier. You can purchase the book through Apple Bookstore and it works on your iPhone, iPad and Mac. The link is available in the description below. Thank you for your support and I wish you a great success in your IB adventure. See you in the next video.